Welcome to section 921. We're going to be talking about imaginary numbers today. Now, we have two main number systems. We have the real, which is all the numbers we've been talking about up to this point, and we have the imaginary. So our real numbers and the imaginary. Now, the imaginary number, the imaginary unit, lets us take the square root of a negative number. So the imaginary unit, all it is the square root of -1, which is I. And that's what it's there for. We also have irrational numbers. That's a real number. It's something like the square root of 3. It's that non-repeating, non-terminating decimal. I, our imaginary unit, is the square root of -1. And when we talk about a complex number, it's in the form of a plus bi, so something like 5 plus 2i or -5 minus 7i. Those are complex numbers. It has the real, the first part, and the imaginary part. And we always write them in that form, the real, then the imaginary. So we're going to talk about simplifying some radicals now. So when simplifying radicals, we have that product property. Now, the product property says the square root of a times b is the square root of a times the square root of b. That lets us simplify radicals. Now, talking about simplifying our perfect squares, 0 squared is 1. So 0, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, and it keeps going. Those are our perfect squares, just like we've been doing before. So we're going to be simplifying. So 50 is the same as the square root of 25 times the square root of 2. So we simplify that, we get 5 square root of 2. Done that before. The square root of 117. Largest perfect square factor is 9. It's the square root of 9 and the square root of 13. So it's 3. Square root of 13 is our simplified radical. For the square root of 44, it's the square root of 4, square root of 11. So it's 2, square root of 11. Now, this is where we get to the new material. -75, the square root of that. So what it is, it's the same as the square root of -1 times 75. So it's the square root of -1 and the square root of 75. So it's the square root of -1, which is I, and the square root of 75 is the square root of 25 and the square root of 3, like we've been doing. So you get is I times 5 times the square root of 3. Now you're going to commonly see that written as 5i square root of 3. And that is our answer. For the square root of -36, -36 is -1 times 36. So it's the square root of -1, square root of 36. So it's I times 6 or 6i. And that's all we're doing. The square root of -1 is I. -200. We have the square root of -1 and the square root of 200, which is 100 times the square root of 2. So it's I times 10 times the square root of 2. So it's 10i square root of 2. And that is our answer. Now, what we have next is 2i times 3i. Now, keep in mind, I'm going to do some work off to the side here. I is the square root of -1. So if we square I, if we have I squared, that's the square root of -1 squared. So what we see is that I squared is just -1. That's what I squared equals. It equals -1. And keep that in mind, that I squared is -1. So what we do is 2 times 3 is 6. I times I is I squared. So all it is 6 times -1, which is -6. And there's our answer. When we square the 2i, we get 2 squared times I squared, and then we have the negative 5 times negative 5I. 2 squared is 4, so it's 4. I squared is negative 1 times negative 5I. Multiply the constants. 4 times negative 1 times negative 5 is 20, and then we have the I, so 20I is our answer. Number 9, 12 minus, and the square root of negative 64 is the square root of negative 1, and the square root of 64. So it's 12 minus, the square root of 64 is 8, so it's minus 8I. And there's our answer in that standard form of a complex number, 12 minus 8I. 10 plus the square root of negative 7, so it's 10 plus. Square root of negative 7 is the square root of negative 1 and the square root of 7. So it's 10 plus I square root of 7. For number 11, we can simplify both of these. It's the square root of negative 1 times the square root of 25 plus the square root of negative 1 times the square root of 36. So it's going to be 5I plus 6I. Now we can combine them. 5 plus 6 is 11, so we have 11I. And number 12. 2 to the third times I to the third. So it's 8. Now, I to the third is the same as I squared times I. So what it is, it's 8. I squared is negative 1 times I. So in the end, we get negative 8I. And there is our final answer. Next page, please. What we can do is we can simplify these. It's going to be 4 plus or minus. Now, the square root of negative 50 is the square root of negative 1, square root of 25, square root of 2, and that's all divided by 2. So it's going to be 4 plus or minus. Square root of 25 is I, square root of 25 is 5, square root of negative 1 is I, so it's 5I square root of 2, all divided by 2. Now we're going to go a little bit further with this so we can simplify. Split them up so they both get their own denominator. 4 over 2 plus or minus 5I square root of 2 over 2. So when we simplify, we get 4 plus or minus 5I root 2, over 2. Sorry, it's not 4, it's a 2, plus or minus all that. Do the same thing for number 14. 6 plus or minus. Now the square root of negative 72 is the square root of negative 1, square root of 36 and the square root of 2, all divided by 4. So it's 6 plus or minus. Square root of 36 is 6, square root of negative 1 is I, so it's 6I root 2 divided by 4, and then split them up. 6 over 4 plus or minus 6I root 2 over 4 becomes 3 halves plus or minus 3I root 2 over 2. And there is our simplified answer. Now we're going to solve using these same rules. We've solved before. What we're going to do is for 15, we're going to solve by square roots. So we get x equals, don't forget, 2 solutions, plus or minus. And the square root of 24, we're going to simplify it. Square root of negative 1. For 24, it's the square root of 4 times the square root of 6. So x equals plus or minus. Square root of 4 is 2. Square root of negative 1 is I root 6. And there's our answer. Number 16, subtract 11 from both sides. X squared equals negative 8. Take the square root of both sides. X equals, 2 solutions are plus or minus. Now the square root of negative 8 is the square root of negative 1, square root of 4, square root of 2. So x equals plus or minus 2I root 2. And there's our answer. Number 17. Once again, isolate the x squared. Add 7 to both sides. 3x squared equals negative 24. Divide both sides by 3. x squared equals negative 8. Take the square root of both sides. X equals, two solutions, plus or minus, square root of negative 1, square root of 4, square root of 2. So x equals 2I root 2. Only thing we're doing here, like I said, is we're adding the square root of negative 1, that I, into our problems. Number 18, subtract the 38 from both sides. 5x squared equals negative 35. Divide both sides by 5. X squared equals negative 7. Take the square root of both sides. X equals, two solutions, plus or minus, square root of negative 1, the square root of 7. So x equals plus or minus I root 7. And that's our answer. Number 19, continuing on, we don't want to square the binomial, isolate it. Divide both sides by negative 5. The quantity of x minus 3 squared equals negative 2. Take the square root of both sides. X minus 3 equals, plus or minus, square root of negative 1, square root of 2. So x minus 3 equals plus or minus I root 2. And then add 3 to both sides. So x equals 3 plus or minus I root 2. There's our answer. Number 20. Divide both sides by 2. The quantity of x plus 4 squared equals negative 20. Take the square root of both sides. X plus 4 equals, plus or minus are two solutions. Now it's the square root of negative 1, the square root of 4, and the square root of 5. So x plus 4 equals, plus or minus, 2I root 5. Subtract 4 from both sides, so x equals negative 4 plus or minus 2I root 5. And there is our answer. Continuing on, to get rid of the negative 1/2, I'm going to multiply both sides by negative 2. So I get the quantity of x plus 2 squared equals negative 72. Take the square root of both sides. X plus 2 equals, plus or minus, square root of negative 1, the square root of 36, and the square root of 2. So it's plus or minus, square root of 36 is 6, I, and then root 2. Subtract 2 from both sides. X equals negative 2 plus or minus 6I root 2. And then finally, problem number 22. I can't factor it. What I can do is I can use the quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. So x equals, the opposite of 8 is negative 8, plus or minus the square root, 8 squared minus 4 times 1 times 19, all divided by 2 times 1. So x equals negative 8 plus or minus the square root. So it's going to be 64 minus 76. So we're going to get a negative 12 divided by 2. So off to the side here, the square root of negative 12, square root of negative 1, square root of 4, square root of 3. So we get 2I root 3. So x equals negative 8 plus or minus 2I root 3, all divided by 2. So we can split them up. X equals negative 8 over 2 plus or minus 2I root 3 over 2. So x equals negative 4 plus or minus I root 3. And there's our answer. So that was talking about using I to simplify radicals, which we use then to solve quadratics. Okay, thank you, and I will see you in the next video.